And I'm already using A's, B's, C's, and D's over there, so let's use P's and Q's for our matrix. If I'm trying to multiply two matrices together, they're P and Q. Ignore that. Let's just do it like this. I would generally call that product of the two matrices P and Q, PQ. But PQ only exists if some of my dimensions match up. So let's say generically the dimensions for matrix P are m by n. And let's say the dimensions for Q are little p by little q. In order for that product to actually work, the two numbers in the middle right there have to be the same. Okay? So the number of columns in the first matrix have to be the same as the number of rows from the second matrix. Okay? So the way we say this is if n equals p. Okay? If those two numbers really are the same, then PQ is a M by Q matrix. Okay, that's an M by Q. Only under the condition that the two numbers are the same. Does that work? We'll play with it, don't worry. Okay? If the two numbers are not the same in the middle, then PQ does not exist. Okay? So before we get to actually multiplying two bona fide matrices together, I want to play with these dimensions first. Alright, so let's make up some matrices. Let's say matrix M is a 3 by 4 matrix. Let's say matrix N is a 4 by 2 matrix. And let's say a third matrix P is a 1 by 3 matrix. Okay? And maybe I'll add a fourth one on in a second. If those are the dimensions of those three matrices, here's what I'm going to do. I'm going to give you a product, and I want you to tell me what the dimensions of that product are. Okay? So let's just start with the first two, m times n. If I tried multiplying m and n together, first off, could I? And if I can, what do I get? What are the dimensions of m? 3 by 4. And the dimensions of n are 4 by 2. Are those two numbers the same number? So what I get is a 3 by 2. If I take a 3 by 4 matrix times a 4 by 2 matrix, I get a 3 by 4 matrix. No, 3 by 2 matrix, I lied. I wrote it down right though. Okay? Now here's what's crazy, and maybe unexpected for some of you. Let's turn it around. What's n times m? That's a problem, isn't it? Yeah, if I try to take a 4 by 2 matrix times a 3 by 4 matrix, those two numbers aren't the same, so n times m doesn't exist. Now think about that for a moment. And what's the obvious conclusion that we draw from that? Is m times n the same thing as n times m? If one exists and one doesn't, they can't be the same thing, right? Matrix multiplication, spelling out all of these words, that important, is not